Last problem on your review. I want to determine the area of this composite figure. So what I have here is a very interesting piece. This is a sector. So I've got a sector here. And I also have a kite. I tell you that the radius is 8 centimeters. All right? And FE is 12 centimeters. I have a bunch of congruents here. And by the way, this is a 90 degrees. So if I have a right isosceles triangle, hopefully you're going to remember that that's 45, that's 45, and that's 45, and that's 45. So I could put the 8s here, and remember to go backwards from the hypotenuse. If you look at your math chart, to go from the hypotenuse to the shorter leg, you divide by square root of 2. So this is 8 divided by square root of 2. If I rationalize it, so I'm going to have 8 square root of 2 over 2, which is just basically 4 square root of 2. So that's 4 square root of 2, 4 square root of 2, 4 square root of 2. So believe it or not, I'm actually ready to find the area of the kite piece. So the area of the kite, there are a couple ways you can do it. You can go ahead and find each triangle in here and add them all up. But hopefully you remember that the kite and the rhombus formula on your math chart, 1/2 diagonal 1 times diagonal 2, that saves you a lot of time. So diagonal 1, we'll call this diagonal 1. We're going to say isn't that really just 8 square roots of 2? Because you got 4 square root of 2 plus 4 square root of 2. That's 8 square root of 2. Diagonal 2 is a little trickier because you got 4 square root of 2 and 12. You can't say that's 16 square root of 2. You actually have to plug it into your calculator, 4 square root of 2 plus 12, and then just have it figure it out, all right? So let's go ahead. I'm going to change that to 4 to make less division on there. And I'm going to do this part first because that's a little messier. So 4 square root of 2, get out of the square root, plus 12, enter. And then times 4 square root of 2. Enter. So the area of my kite is 99.88 square centimeters. All right, so that's one piece. Now I have the sector area, and you're probably going, wait, you don't know the angle, or do you? How many degrees is this? 45. That's 45. Guess what? This makes a right angle. So since that makes a right angle right there, then this has to be 270 degrees. Right? So the area of my sector is, remember we have a proportion actually, let me do it this way. So I can say 270 over 360, 3/4 of the circle, my sector area should be 3/4 of the whole area, which is going to be pi times r squared, 8 squared. I'm going to go ahead and simplify this. Hopefully you should see that 270 divided by 360 should be 3/4, and you can see it's 0.75. If you hit math and you wanted to change that to fraction, it's 3/4. So I got 3/4 equals a sector of 64 pi. What that means is that this sector is 3/4 of that 64 pi. So I can multiply both sides by 64 pi. If you wanted to, you could cross multiply, it'll all work out. So I have 64 times 3 divided by 4, which should work out to a nice pretty number, 48 pi. So the sector area is 48 pi. All right? So the total area is going to be this sector plus that kite. A total equals area of the sector plus area of the kite. So it is 48 pi plus 99.88. Since I've already rounded here, I might as well go ahead and round this whole thing. So 48 pi plus 99.88. So you can see I'm just putting that in the calculator, hit enter. 250.67. It's approximately. Honestly, probably 251 or 250.7. These will all be good answers. Voila, and there's your answer.